there is one batch added of 11th class, no? That's why.
So, sir, like this will be forever, like 5:30.
Yeah. Are you
Sir,
not comfortable? Are you not comfortable with it?
yeah, sir, because like I have to like after finishing
You
tuition, I have to do my tuition, like tuition work and then
okay,
school work,
okay.
study for
You can
projects and all.
for this, na, if this is the thing, na, then you can talk to the Learnivio. Okay.
Okay.
I will talk to the Learnivio for that. Okay.
Yeah,
So
like because like 4:30 is also fine. Like because after 5:30, I have some work and all.
yeah. No problem. You can. I will tell, and then
Yeah, yeah,
you should also tell that you
yeah,
are just.
yeah. I will tell my father that message to message them.
Okay. So, Harsh, what we were discussing the magnetic effect of current or
Yes,
the
sir.
moving charges and magnetism.
Yes,
Okay,
we were in
so
Biosav's law.
just Biosavart law we have just started, and today is the thing that I am going to teach means the direction part of Biosavart law. Means
Yes, sir.
not the Biosavart law, means how to calculate the direction, and that is very very important. Okay. So this is we have just completed. What we have completed, just I am revising it once. Uh, so we have discussed what are the sources of magnetic field. So there is three sources we have discussed. First is current, and second is earth, and another is electronic field. And about the magnetic field, I have discussed with you what is the magnetic field, and like the electric field, there is a magnetic field. You can define. And after that, I have discussed the Biot-Savart law. So with the help of Biot-Savart law, you can calculate the magnetic field at a point due to a element of the wire, due to the element or a small element of the wire. And this is the scalar form. dV is equal to mu naught upon 4 pi IDL sin theta divided by R square. And I is the current flowing in the wire. DL is the elemental length of the wire. Theta is the angle between the position vector and the DL vector. R square is the distance. Okay. And in vector form, this is the Biot-Savart law. In the vector form, this is the wire. In terms of current density, if suppose in the examination someone is asking what is the Biot-Savart law in terms of current density, then you can drive with the help of this. Okay. And
Yes, sir.
after that, there is a term means in terms of velocity of charge. In terms of velocity of charge, if you want to calculate the magnetic field, then accordingly you can drive, and you will get 2 marks or 3 marks depending upon the exam. And this is the thing that till now I have told you. Now I want to talk about the direction and the vector or sorry cross product and the direction of the magnetic field. How to calculate the direction of the magnetic field? Okay, due to a wire. So uh, first, I want to tell you. Do you have any idea about the cross product?
Yes, sir. A into B is C, AB cos theta and all that, right?
Actually, that is dot product. Okay, no problem. Just the topic is the direction of magnetic field. Uh, we will discuss here the direction of the magnetic field. So earlier, what we have done, I am telling you the whole story. And earlier, what we have done, we have just calculated the magnitude of this magnetic field due to this current element at this point. But we don't know what is the direction of magnetic field at this point. For
Yes, sir.
that purpose, that I am just discussing that part. So see here, direction of magnetic field. Direction of magnetic field.
Well, like IJ cap, K cap, right?
Yeah, you are right.
Oh
Means
yeah, sir. We
hmm.
have studied that circle, sir. I cap into J cap is equal to K cap minus I cap into that cap, right?
Yeah, you are right.
Yeah, I have studied that. I forgot. Like, I
For the
forgot this
direction,
vector product and
okay,
all.
no problem. I am here. Okay, so for the direction of the magnetic field, first you should know what is cross product. Okay, what is cross
Yes,
product?
sir. Yes,
Suppose
sir.
there is a vector A vector, and this A vector is the cross product of V vector cross C vector. So this is known as V vector cross C vector,
E
and
vector.
and A vector is equal to V vector cross C vector. And if this is the condition, then you can say the A vector perpendicular to V vector, as well as A vector will be perpendicular to C vector. Okay, this is the condition. So in the Biot-Savart law, in the vector form, and suppose if you want to calculate the direction, na, then this formula in the vector form will give you the magnitude as well as direction. Because in the
Okay.
for vector, there is a requirement of direction and magnitude. Okay, so it
Yes,
means
sir.
that for the calculating the direction, this formula will be used. Okay, most of the time. Okay. So you
Yes, sir.
can see here, this dv is the cross product of dl vector and r vector. So you can write this dv vector must be perpendicular to dl vector, and this dv vector must be perpendicular to position vector. Okay,
Yes, sir.
this thing is very important. Okay, so I can write from here. From here I can write dv vector is perpendicular to the plane containing dl vector and r vector. So this is the thing. And one more thing I want to tell you about the direction. So so this is the these are the, suppose this is positive x-axis. Suppose this is the positive x-axis. This is the negative x-axis. Suppose this direction, negative x-axis, and this direction you will take positive y-axis, and this direction you will take negative y-axis. And one thing more you should know: in this direction, the unit vector is j cap, and in this direction, the unit vector is minus j cap, and in this direction is unit vector is I cap.
Yes, sir. X axis is y cap. J cap is y
Here is
axis.
minus I cap,
J cap.
the unit
Yeah,
vector.
minus I cap.
These are the unit vector. These unit vector will be used for defining the direction of the magnetic field. If suppose I
Yes, sir.
have written the magnetic field in terms of I cap, means it means that the magnetic field is along positive x-axis. If I have written the magnetic field in terms of minus j cap, it means that the magnetic field is in the direction of negative y-axis. And there is one more axis, z-axis. So that z-axis part is that I want to explain you what is that z-axis. And z-axis is like this, but for the z-axis you should imagine the things in 3 dimension. Uh, this is the z-axis, positive z-axis, and this is negative z-axis. Negative z-axis, and unit vector for this is minus k cap, and this is positive z-axis
Yeah, and that's negative z axis.
minus k, sorry, plus k cap is the unit vector for it. So now I have made this x-axis and y-axis on the screen. Okay,
Yes, sir.
if suppose I am just removing this. what is the meaning of z-axis? Always remember that I am assigning the direction, and throughout the chapter I will use these directions only. Your
Yes, sir.
plane of copy, in which you are writing, or your screen will be considered as xy plane always. Okay, I will consider
Yes,
your
sir.
plane of copy or plane of your screen as the xy plane. Why I will consider that as xy plane? Because at your screen of your laptop there are only two axes. One is x-axis and another is y-axis. This z-axis
Yes, sir.
is not on your screen. Okay, this
Yes,
z-axis
sir.
will be like this. Okay, just I am giving you the example. Suppose this is your screen. Okay, this is your screen of your laptop, and what is happening here? This is your xy plane. Means xy plane means this plane have two axes. Your screen of your laptop have two axes, x-axis and y-axis. Okay, so if there will be any other axis, that will be like this. Okay, just see here. So if there will be any other axis which can be like this only. Okay,
Yes, sir.
means if this is your screen of your laptop, then another y-axis will be like this. Okay, y-axis will be perpendicular to this plane, or
Yes, sir.
this can be like this also. Okay, in this
Yeah.
direction also, in this direction also, means in this direction also, or in this direction also of your screen. Suppose your screen is like this. So suppose if this is like this, means this axis is like this, means if you will rotate it, it will be like this. So means you will take this as a negative z axis. Downward direction, I have just rotated this plane, no problem. Downward direction means uh, here I am sitting, here is this downward direction, and for you this direction will be the direction. If this is like this, if the if something is going, you can just take it in a simple way. If something is going into your screen, then you will say
Yeah.
that thing is going in the negative z direction. If
Yes, sir.
something is coming out of your screen, coming out of your screen or your paper, then you will say the thing is in the positive z axis.
Yes, sir.
So this thing is a negative z axis, and this you will say inwards, and this inwards is represented by this cross, and this is positive z axis, and this positive z axis is outwards, and this outwards I will represent, and I will not represent means this is given in NCERT. So we have to represent the outward means something is coming out of the plane of your screen, then you will represent it like this. And unit vector in the minus z direction will be minus k cap, and plus in this direction will be plus k cap.
Plus K cap.
Okay. Now we will discuss the right hand thumb rule. Now we will discuss the right hand thumb rule, and with the help of right hand thumb rule, we will just calculate the direction of the magnetic field. Right hand thumb rule. First, I will write the definition part. So they are saying that hold the current carrying wire in the right hand in such a way that your thumb Point out the direction of current.
Yes. And the curled fingers gives the magnetic field.
Yeah, point out the direction of current, then curvature of your finger. Curvature of your finger will give you the direction of magnetic field.
Magnetic
Will
field.
give you the direction of magnetic field. Now, this is the theory, and how you will apply this. Let's see. Suppose earlier we have this condition, and I am copying it here. And earlier we do not know the direction. Suppose I want to just find the direction of magnetic field at this point. So what I will do, just imagine this picture, or you can draw this picture on your paper. Okay,
Yes,
because
sir.
I will stop sharing my screen. I will tell you with my hand. So what you will do now, see here, this is the current carrying wire. Suppose this is the
Yes.
current carrying wire, and the direction of the current in this wire is along which axis is this?
K. Sorry, J.
No problem. Okay,
Y
no
axis.
there is no requirement of axis this time. Okay, so I am just saying that current is going in this direction. In this direction the current is going. What you will do, just think, and you have to calculate the magnetic field. Suppose at this point here is a point, here is a point that you have to calculate the magnetic field. This is the
Yes.
point. Okay, you have to imagine this in your mind. What you will do, you will take your right hand first, and you will
Yes, sir.
point your thumb in the direction of the current. Point
Yes.
your thumb in the direction of the current, and point your finger towards the point where you want to find the magnetic field.
Yes.
This is something different, means you have to point your thumb in the direction of the current and point your finger in the direction of the point where you have to find the magnetic field, and just now curl your finger 90 degree. Just curl your finger 90 degree. What is the direction
Yes.
this time? The direction is going towards the screen, means into the
Yeah, it's
screen,
minus axis.
means minus k cap. Okay, so you can do this, and when you will curl your finger 90 degree, and the direction that you will get after curling your finger 90 degree is the direction of the magnetic field. So here you will get the direction of magnetic field inward,
Yes, inwards.
and inwards is represented by this cross
Dot
sign,
X.
x or cross sign, and this is the direction of the magnetic field inwards. And suppose here is a point. Suppose here is a point. Now here, see here what will happen. If suppose here is a point, you can imagine just here,
Yes,
this is the current carrying conductor, and here is a point somewhere, and you want to find the direction of current. What you will do, you will just point your thumb in the direction of the current, point your thumb in the
Yes.
direction of the current, and point your finger in the direction of a point where you want to find the direction of the magnetic field, and just curl your finger
Direction of
90
magnetic.
degree. And what direction I am getting?
It is
Towards the
outwards.
observer, towards the observer, towards me, or out of the screen, you can say. So in this way you can just find the direction of the magnet. So here is the direction will be outwards,
Outwards.
and outwards is represented by a dot. So here the
Dot.
direction of magnetic field will be like this. So this is the part of application, means in this way you have to apply the
Right hand thumb rule.
right hand thumb rule. This is the easiest way according to me.
Yes, sir.
Okay, just hush. Now suppose you have this wire, and I am saying that what will be the direction of magnetic field at this point?
Okay, so just a minute, I'll do it.
Okay, okay, no problem.
Sir, it is outwards.
Yeah, very good. And suppose the point is here.
It is still outwards.
Very good. Now suppose the point is here.
It's inwards, right?
Yeah, you are right. Just I am explaining it once, and after that we will. This was the wire, na? So
Yes,
here,
sir.
though, here you know the outward. How you will calculate the direction? Suppose if here is the direction, someone asks. This is the wire, tilted wire. So what you will do?
Yeah.
You will just point your thumb in the direction of the current and point your fingers in the direction of a point where you want to find the direction and just curl it at 90 degree. You will
Yeah.
get direction. Okay. So here you will get outward, here you will get inward. Inward means this, oh sorry, this, and outward means this, outward means this. Because this inward is looking like this, na? So you can suppose this as a arrow is going into your screen. So the arrow is something like this, na? We draw arrow
Yes, sir.
like this,
Yes, sir.
means
Yes,
as
sir.
like this. I think in 3 dimension, have you seen, means this arrow is this is the tail of the this is the head of the arrow, and this is the tail of the arrow. So this sign for inward is due to this tail of the arrow. Tail of the arrow is like cross. So this is looking like the arrow is going into your screen, and this is looking like that the head is coming out of your screen, head of the arrow. Okay. So this is
Yes,
the
sir.
basis for the direction given by the NCERT. Okay. So now I will discuss a numerical on this. And here we will use the method of that means. Okay, so this is the question. Okay. Now I know that you can find the direction of the magnetic field. You can see the direction of the current is in this direction, and if you want to find the direction, then you will do like this, and this will be coming
Yes, sir.
towards you or outward. You already know.
Outwards.
Outward.
Outwards.
You already on magnitude you can find with the help of Biot-Savart law. But there is a thing that I want to tell you here. See here. Here is a length element given. Delta L element is given. Okay. This time for I am not taking DL, I am taking the delta. And delta N and DL is a thing like the average velocity, and average velocity we represent with delta V, or the instantaneous velocity we will represent with dV. So I am taking delta, okay, there is no problem. So delta L, the value of delta L is given as 0.01 meter. Okay. So now can I find delta L vector? Can I find delta L vector?
Yes.
So here in this direction, the unit vector will be I cap, and in this direction, yeah, unit vector will be J cap. If we want to find the vector, then we should have the magnitude as well as direction. Okay, so we will have the magnitude of delta as 0.01. So first we will write the magnitude 0.01. Then we will multiply it with the unit vector. What is the unit and what is the direction we will take for this delta L? Direction of the current we will take now.
Yes, sir.
And direction of current is along x-axis, so we will take this
X-axis.
I cap.
I cap.
So I cap. So this is the delta L vector, and so this is suppose the distance r. This is the distance r, and this is given as 10 meter. Can we find r vector? Can we
R
find
vector.
yeah. So r vector in the same way we know the
Yeah.
magnitude.
We can.
10 j cap will be the r vector.
Yeah,
Just
10
write the
J cap. Yes,
magnitude
sir.
of r and multiply it with a vector. Here is this point, na? Here this is the r. R is along y axis, na?
Yes, sir.
This is along y axis, so you will take here the j cap. Now I want to tell you the thing that you are saying at that time.
I, J, K, they
I,
just multiply it.
J, and K. And I want to tell you before that, if A cross B is written, then you will
It will be
write
C.
AB sine theta
Yeah.
and you will take n cap. Okay.
Yeah.
So this is the thing you will take. And suppose if you want to find I cross J, then I
I
cross
cross.
J will be K.
Yeah. I
Okay.
cross J will be K.
K.
K cross J will be I minus
Yeah.
I.
If that will be, so this will be K. If you want to find J cross K, then it will be I.
I.
You have to move in a particular direction in a circle.
Yeah.
So J cross K equal to I. So J cross K equal to I cap. And if I cross J, if K cross I is equal to J, K cross I equal to J,
Yes.
K cross I equal to J. Suppose a random thing I have given. If suppose I want to find J cross I, J cross I, if you want to find, so J cross I means you have to go in the opposite direction of the circle, in the opposite direction that you have taken direction. From your taken direction, you have to go into opposite direction. Then you this will be become
Yes. So J cross
minus
I will be minus K cap.
minus K cap. So accordingly, you will
Yes.
just find. So this is the thing. Now I want to find this delta V is a formula. I will apply here. Mu naught upon 4 pi I will be delta L vector cross R vector into divided by R cube. Okay. So if you want to find the delta V, now you will see this formula will give you the direction L as well as magnitude. Okay. So delta V vector is mu naught upon 4 pi is equal to 10 to the power minus 7. And what is the value of I here is 10 ampere.
Yes, sir.
And what is delta L? Delta L you will take 0.01 into I cap. And cross, what is R vector you will take? This is J cap you will take 10 J cap. And this is divided by R cube means 10 cube. Now see. Now see, this is delta V vector and this is 10 to the power minus 7. Then you will, and uh, this will become 10 to the power minus 10. And this will become 10 to the power minus 9. Here you will get. And now what you will do, Harsh, for multiplication of this, you will multiply this numerical value with this first.
Yes, sir.
So you will multiply this 0.01 with 10, then you will get 0.1.
Yeah.
And you will multiply I cross J. And what is I cross J?
K.
That is K. So here you will have 10 to the power minus 8.
Yeah.
Not 10 to the power minus 8, 10 to the power minus 10 you will have.
Yeah, because
Just see why this is 10 to the power minus 8. This will become this now when you will remove the point.
yes,
This
sir.
will become
Yes.
10 to the power minus 10 and I cross J is equal to K cap.
Yes.
So see, you have got the direction as well as magnitude with the help of this formula 10 to the power minus 10 K cap. 10 K cap means the direction will be out of your screen.
Yes, sir.
Okay, means outwards. K cap
Yes, sir.
represent the outwards. Magnetic field will be outwards and outwards is represented by this. And or you will apply the right hand thumb rule, then again you will get the same answer. Just do that. Point your thumb in the direction of the current and point your fingers in the direction of a point where you want to find the magnetic field, and just curl your finger to 90 degree, and the 90-degree direction of your finger will give you the direction outward. Okay, just now you can note it down.
Yes, sir.
And this is a question from NCRT.
So I can just scroll up and write the right hand row.
Okay. Scroll up means I have to go here. Okay. You have to write this axis also, na?
Sir, it's already in my physics notebook.
Very good. Harsh, when completed, you can ask me to move to the next page.
Yes, sir, just a minute. I'll
Okay.
tell you, sir. Done, sir. Scroll down. Sir, thank you. So, can you scroll down? Done, sir.
Harsh, completed?
Yes, sir. Yes.
Should I move now?
Yes, sir. You can also done.
Now, Harsh, we have just discussed the what we have discussed. We have discussed the Biot law.
Yes, sir.
Now we will discuss the application part. Application of Biot law. Just write the heading.
Yes, sir.
So basically, in Biot law, mostly according to your syllabus, we will study three topics. We will study mostly three topics. First thing is we will study magnetic field, MF. In short, I am writing. Is it fine now?
Sir,
Magnetic
yes,
field.
yes, sir. Yes. Magnetic
Yeah.
field. Or you can also write B, sir. No problem.
I know that. Magnetic field due to a straight wire. First, we will discuss about this and magnetic. After that, we have the application of Biot law. Means with the help of Biot law, we will calculate the magnetic field due to a circular wire. Circular wire, and thirdly, we will discuss magnetic field due to an arc. Arc, circular arc. Circular arc. This is the three things that we will study in the Biot law, means for the application part. And okay, so just please note it down. I am moving to the next slide.
Yes, sir. Yes, ma'am.
Yeah, okay, no problem. You can write it down.
Done, sir. You can continue, sir.
First, please write down the heading magnetic field due to a straight wire, but the
Yes.
derivation part is not in your syllabus. We will
Okay.
do this derivation with the help of Biot law, or not Biot law, Ampere circuit law.
Okay, so B is equal to mu 0 I by 2 pi r. That equation, right?
Yeah. Okay, you can write down the heading, and
Yes, sir.
after that, I am just writing the form. I will just write the
Yes.
formula only.
Yes, sir. Yes. So done, sir. I wrote the heading.
Okay, fine. Suppose this is the straight wire, and suppose this is some point here. Suppose this is the point here, P point. Suppose this is the point P, and this is the straight wire, and in this wire, suppose the current is flowing like this. Current is flowing, and due to this wire, suppose the wire is AB, straight wire is AB, and suppose due to this whole wire, you want to calculate the magnetic field at this point P, and this distance A is the perpendicular distance. Okay, suppose this distance is A from the wire, and this A is the perpendicular distance. What I have told you, according to the Biot-Savart law, we can only calculate the magnetic field due to the element of the wire, not for the whole wire. So suppose someone is saying just calculate the magnetic field at this point due to the with the help of Biot-Savart law. So what you will do? You will just calculate the magnetic field with some small elemental length of the wire, and you will integrate that. You will integrate that, then you will get for the whole wire. If you will give the entrance examination, then there this derivation is there. Then so what you will do, you should join these 2 points, the end point of the wire, and this end points in making an angle. Suppose this is making an angle phi 1, and this suppose is making an angle phi 2 with this point P. Okay, and this distance is A, and then you will get the magnetic field at this point P is equal to mu naught divided by 4 pi, mu naught divided by 4 pi I by A sine of phi 1 plus sine of phi 2. So this is the formula that you will get when you will integrate it. Okay, so this is the formula that you should remember. This formula is the part of your syllabus, and the derivation is not the part of your syllabus. And for the direction, what you will do? Same thing you will apply. For the direction, right hand rule you will apply for the right hand. And can you tell me the direction of the magnetic field at this point due to this current carrying wire? Will be inward or outward? Yeah, at point B. Will be inward or outward?
At point P, it will be outwards.
Just do it once again. Okay, now see here. If you are not getting, then you can see here. Okay, see here. We have this wire. We have this wire now, and we have to calculate the magnetic field at this point. What you will do? We will pointing our finger. Pointing our thumb in the direction of the current, and current is going upward.
Yes, sir.
And we will pointing these fingers in the direction of a point, means along a point.
Oh yeah, it's inwards. Then 90 degrees.
It will be like this, means it is going away from me. Away from me means going into the screen. Yes, means negative z axis. So you can see. Okay, fine. So the direction will be inwards. Yes. The direction of magnetic field will be inwards is represented by this cross. And this is also in the for the unit vector sense. If we are talking, that we will say that the direction will be in the negative z axis, and that is given by minus k cap. Yes, sir. So direction of this you can find with the help of right hand thumb rule. So I am writing here. Just note it down, then we will move forward, and we will use this formula for driving the other results. Okay? Yes, sir. Yeah. Done, sir. Then okay, write this also. So direction, so you will find always with the right hand thumb rule. Yes. Okay, and the direction part is right hand thumb. Okay. Now the first application, magnetic field due to a infinitely long conductor.
Sir, just a minute, I'm coming, sir. 1 minute.
Means this thing, this time we are just talking about the straight wire. Okay, so this is a formula for the straight wire only. This is the wire of finite length. Okay, AB is the wire of finite length. I am just writing here. AB is a wire of finite length. Just remember this point, and we are going to just calculate the magnetic field of a wire, magnetic field due to a current carrying wire of infinite length. Should I move now? Oh. Okay, Harsh, now repeating my voice. Harsh, now
Sir, can you hear
repeating.
me?
Yeah, of course I can.
Sorry, sir. My internet got disconnected.
Okay, no problem, that's fine. So have you written this?
Yes, sir, I wrote that.
So what I want to say that this is a wire of finite length, and due
Yes, sir.
to this wire of finite length, the magnetic field is come out to be this. Okay, this is the angle. See this angle. What is the angle? Now we will discuss some special cases of this. Okay, due to
Yes, sir.
special cases of straight wire, and first case is the magnetic field due to a infinitely long conductor, long wire. Infinitely long wire means you will take a wire of infinite length. Suppose I am taking a wire here. This wire is having a length, infinite length means you can say like this. This is plus infinite. This is minus infinite. Okay, and minus infinite. So this is a wire of infinite length. Please write the heading first. In magnetic field due to a infinitely long conductor.
Done, sir.
Okay. And I want to find the magnetic field due to this wire at this point. Suppose at this point. Okay. So this is the point. This is a point P, suppose. And again, this is at a distance A, and this A is again a perpendicular distance. So what
Yes,
we
sir.
will do, we will just okay, join this point with this, and but please remember here this wire is infinitely long. Infinitely long means very long.
Very long.
So when this wire is infinitely long, so what will happen? Just please try to imagine this. Means this is looking like very this angle is looking like the angle. Some angle means lesser than 90 degree, but this angle is 90 degree actually. When the length of your wire become infinite, this angle will become 90 degree. Means you can say that if this wire is very large, then with respect to the length of this wire, this A distance is very small.
Yes, sir.
Yeah. So when you will just, okay, no problem. Just here is a point. Here is a point, and this wire is going like this, like this, like this. Suppose if I am having a point on this wire, and just I am just meeting this point with this wire like this. Why this is not working? Now it's working. So you can say say that this time suppose we don't know what the angle is, this angle, okay, we don't know what this angle. So when you are moving upward and you are joining with this point, so this angle is increasing, and when the finally the length of the wire will become infinite, this angle will become 90 degree. Okay, this angle will become 90 degree. So you can write this angle as 90 degree, and you can put that value in the formula, and you will get your answer. So why the angle becomes 90 degree? Because the wire is of infinite length we have. So the formula will become what the formula due to the finite wire? V is equal to mu naught divided by 4 pi I by A sine phi 1 plus sine phi 2, and this time what is phi 1 and phi 2? Phi 1 and phi 2 is 90 degree. Harsh, getting?
Yes, sir. Yes, sir. Yes, sir.
Phi 1 and phi 2 this time is 90 degree na. So just
Yes,
put the
sir.
value. When you will put the value, you will get mu naught divided by 4 pi, and this is I divided by A sine 90 plus sine 90, and what is sine 90?
Yes. 1.
Very good. And this is 1, this is 1, this will become 2, and this will become finally mu naught upon 4 pi 2I divided by A. 2I divided by A, and this is the formula you have to remember when your wire having the length of infinite. This is the magnetic field at this point, and direction part you can use your right hand rule, thumb rule. Okay, so here if you
Yes,
want to find the direction, suppose the
yes, sir.
current is flowing here in this direction I, and direction will be again will be into the screen,
Yes,
means
sir.
the direction will be like this. So just please complete this case, and after that we will discuss next case.
Yes, sir.
For the timings, I will talk to the team. Okay.
Yes, sir. Yes, sir. Thank you, sir.
If you are analyzing the problem in physics in a proper manner, means analysis in physics is very important part.
Yes, sir.
If you know the formula, then it's good. But if you are understanding the things properly, then it is very good.
Yes, sir.
Formula, everyone can learn the formula and apply the formula and put the values.
Done, sir.
Okay, so this is the first case, magnetic field due to a infinity log conductor, and second case we have magnetic field due to a magnetic field due to a semi-infinite conductor at a point lies near to one end.
Yes, sir.
Okay, so the meaning of this is taking a wire again, but this time this wire is having a semi-infinite length. Semi-infinite means here the length is infinite, but here is a finite length, and you have to calculate the magnetic field at a point which is at a distance of A from this end. Okay, and suppose this is a point P this time, and what is this angle? You will join this from here. So I have told you, when you will join infinitely wire at point P, the angle become 90 degree. Mean this time your phi 1 is equal to 90 degree, and what is phi 2? Phi 2 will become 0 degree. Okay, phi 2 will become 0 degree because this point is here. This point is other end. Other end is making an angle, means this is the distance A now. We have discussed.
Yes,
This
sir.
is the distance A, and now this line and this joining point of the wire is same, means the angle will remain 0. Angle will be same, not the same. Angle will become 0. Means, Harsh, are you getting what I am saying? Means this time this point P lies at one end of the wire. Okay, means at a point which is perpendicular to the one end of this wire. You can see here now. You can see here this point, this time P lying here. So when you are joining this, means you are getting the angle 0 degree, and you can put the value in the formula. Okay, when you will put the value in the formula, this is mu naught divided by 4 pi, that is I by A, sine phi 1 plus sine phi 2. What is sine phi 1? Means sine 90.
Sine 90, sir.
And this is
1.
sine 0. Okay, so finally when you will calculate, you will get the answer mu naught upon 4 pi I by A. I by A will. So this is the formula. And for the direction, what you will do? Same thing you will do for the direction.
Yes, sir.
Again the direction will be into the screen or into the paper.
Yes, sir. It's into
or
inwards.
yeah, or in minus j cap, means not minus j cap. What is minus k cap? So this is the another case. Just please note it down.
Yes, sir.
This is the heading was the magnetic field due to a semi-infinite conductor at a point lies near to one end. This is the one end. This is another end. Another end is at infinite, and one end is lies near to this point P, where we have to calculate the magnetic field. Done, Harsh?
Sir, done, sir.
So this is the second case, and now I am taking a case: magnetic field due to a conductor. Magnetic field due to a conductor if point lies on the axis of the
Yes, sir.
wire or along the length. So you can see this case as, again we are having this wire, and suppose we want to calculate the magnetic field at this point P. Okay, at this point P, and this point lying on the axis of the wire.
Yes,
Okay,
sir.
lying on the axis of the wire. So what is the value of phi 1? Phi 1 and phi 2 this time will become 0 degree, because this time this point is lying on the axis. Okay, this phi 1 and phi 2 will become 0, and when you will put the value in this formula, V is equal to mu naught divided by 4 pi, and this is I by A sine of 0 degree plus sine of 0 degree. Okay, and 0 plus 0, this is sine 0 and this is sine 0. This whole thing becomes 0, and when you will multiply this whole thing with this 0, then magnetic field will be 0. So if a point lies on the axis of the wire or along the length of the wire, then you can say there is no magnetic field due to that current carrying wire. Just please note it down. Harsh, when you have when you completed, then you can ask me to move.
Yes, sir. Yeah, just a minute, just a minute.
Okay, no problem. So the angle becomes this time 0 degree, both the phi 1 and phi 2. And that is why you are getting this magnetic field at this point P is equal to 0 degree, 0.
Yes, sir.
If there is no magnetic field, means there is no direction of magnetic field.
Done, sir.
For net magnetic field, we are talking. And not the third case, I will say. There is a point, another case, if the magnetic field, if you want to find if the point lies on the conductor. If the point lies on the conductor, so for this, I will write an statement. For this case, here this thing cannot be calculated with the help of Biot-Savart law. This thing can be calculated with the help of Ampere circuit law. Can be calculated
By Ampere circuit.
with the Ampere. We will discuss Ampere circuit law later.
Yes, sir. Yes.
Ampere's circuit law cannot be calculated. Biot-Savart's law. And this derivation we will do in the next class. Maybe we will do this derivation, but we will do this. We will calculate the value of magnetic field on the surface, or if the point lies on the conductor. This we will
Yes,
do
sir.
with the help of Ampere circuit. So
Yes,
this
sir.
thing we will discuss there when I will discuss Ampere circuit law. So just note it down, and then we will have at least two numericals. We have not two, two numericals we have.
Done, sir.
Okay. So the question part we have now. This is the first question. Here is only one question.
Calculate the magnetic field at point due to now.
Yeah. So this is
So just
the
to
question.
add the question.
Okay, just write the question. This question is again very simple question.
Yes, sir.
And always try to write the question or try to write the net magnetic field in terms of vectors. So
Yes, sir.
along the x-axis you have I cap unit vector. Along the y-axis you have j cap unit vector. Okay. So we can. And along the this axis means z axis, we have k cap. Can you find the answer of this question by yourself? Means this is the point P here.
Yes. Okay, calculate the magnetic field at point P due to now.
And please remember that. Please remember that. These are the wires. Okay.
Yes, sir.
These are the wires of infinite length.
Okay.
Negative point. Long wires written here. Na? Long wires means you
Yes,
will
sir. Yes,
consider
sir.
the wire. Means you will apply the formula V is equal to mu naught divided by 4 by 2I divided by A. 2I
Yes.
divided by
Divided by
A.
A.
Just should I solve or you are solving it?
Sir, I'm solving suggestion.
Now you can suppose this as first wire, you can suppose this as second wire. So magnetic field due to this first wire you can suppose as V1.
V1.
Here V1 you can suppose, and V2 you can suppose due to this wire in the vector form. If you will. So when you will calculate V1, just see here now. You want
Yes,
to
sir,
calculate the magnetic field at this point P. Okay, magnetic field at this point P. So what is the magnetic field V1 at this point P? You will apply mu naught divided by 4 pi 2I 2I1
by A.
by D, because D is the distance this time.
Yeah, okay.
You
Yeah,
can see
distance. Sorry.
D, and this is the magnitude. And what about the direction? Just apply the right hand thumb rule and you will get the
Yes, sir.
direction into the screen. Means minus
Yeah.
minus k
Minus
k
minus
minus
K.
k minus k
Minus
cap.
J. Yeah, minus K.
Not J, minus k cap.
Yeah, minus
Just
K
do
cap.
this.
Sorry, sir.
Means the direction is inward. You will get the minus k cap, and when you will just calculate the this V2. So what is the V2? You will write
Mu 0 4 by 4 pi 2I2 by D.
yeah. When you will calculate this, this is mu naught divided by 4 pi, and again you will write 2I2 this time by D.
Yes, sir.
And now when you will calculate the direction, just apply the right hand thumb rule. Just apply.
Yes.
You will get
Sir,
the direction
outwards.
for outward. You will multiply it with a k cap.
K cap, sir.
And for the net magnetic field at point P, you can add both the vectors simply, because V1
Sir,
plus
we will for net
means
will subtract it because they're in opposite directions.
you are right. You are right. But here we have already written whenever you will write the vectors in terms of k cap. Okay, then always you will add the vector. Automatically, the
Okay.
vector subtraction will take place.
Okay,
Okay.
sir.
Yeah.
Okay.
Now you will see this will be happen, because minus sign is also already included in k cap. So
Yes, sir.
you see here now when you will write this, you can take when you will write this. You can write this mu naught divided by 4 pi. This is 2I1 divided by D, and this is minus k cap, and this is plus. This is mu naught divided by 4 pi, and this is 2I2 divided by D, and this is k cap. And now take the common terms out.
Yes,
what is
sir.
the common term? Mu naught
Mu
by
0
4
by
pi.
4 pi.
And what is the common? Common is 2 mu naught 4
and
pi
4 pi
into D.
and D.
Sorry.
Yes. Sir.
Who's calling? Just a minute.
Yes, sir. Yes.
Okay, just okay. So when you will take common, you will get common 2 into mu naught divided by 4 pi d.
Yes, sir.
4 pi d, and remaining here you will have this I1, you will have this minus I1 k cap,
Minus I1 k cap. Yes, sir.
means minus I1 into k cap, and here you will have plus I2 into k cap.
Yes, sir.
Now you will see automatically there is the minus sign, 2 mu naught divided by 4 pi d, and when you will write this, you will how you will write this is minus I1 plus I2, and k cap you will take common. So now you can see that here
Yes,
minus
sir.
sign is included now.
Yes, sir.
Okay, so the net magnetic field will be like this. Or either you can do that uh, two vectors are in opposite direction, just first subtract the vector and take the direction again. The same thing you will have to do again. Means that thing is also same. Okay, so
Yes,
this
sir.
is the answer. Just write this down.
Done, sir. Done.
So next question. So next is the. I am taking one more question. Okay,
Yes,
I
sir.
have
Yes, sir.
I have not written that question. I think so. I am writing. I think I have taken that question here. Not here. Okay, no problem. I think it's right. So the question is this time something different. Uh, you have this wire one like this, and here in this wire is current I1, and here you have a point. Here you have a point, and again here you have a wire this time. Okay, and time you have a wire. Harsh, this time this is the wire now, and here we have to just calculate the magnetic field at this point P, and this is the wire, and this wire it has a distance of d, and here is a wire. This is also a current carrying wire. Okay, and in this wire the current is going into your screen. In this is a wire in which the current is going into z axis. Okay, negative z axis. This is also a wire, and this is also at a distance of d. Okay, this is the wire 1, this is the wire 2, and
Yes, sir.
this sign showing the direction of the current is into your screen, and you have to just calculate the magnetic field at the point P. So the question is
Yes.
find magnetic field at point P. So just see how I will solve this. And both the wires are long wire, we have already discussed. You will write first formula for V1. What you will
Yes,
do,
sir.
mu naught divided by 4 pi, and this is 2I1 by d. This is the thing now. Due to this wire, at this point the magnetic field V1 will be this, and when you will calculate the direction, just apply the right hand thumb rule. You will get the direction into your screen, means you will get minus k cap.
Yes.
Okay, now just calculate the magnetic field due to V2. Due to V2 means due to the wire 2. This will be mu naught divided by 4 pi,
Yes,
and
sir.
this is again 2. I suppose I2 current is going inwards here. This time the I2 current is going here. 2I2 divided by distance is remain same. This time
Yes.
this condition is something different. You have to imagine in 3D. Means what is happening? Uh, what is happening? Suppose this is your screen of your laptop, and what is
Yes, sir.
happening this time, this is your screen is like this in horizontal plane, and the current carrying wire this time is like this, and the current is
Yes.
going in this direction, means into your screen the current
In
is
my
going.
screen. Yeah, yes, sir.
Yeah, yeah. So this distance is d, so you will write to I2 divided by d.
D.
And now just tell me what will be the direction of the magnetic field.
It will be inwards.
No, this time not inwards,
Sir,
because
sir,
your
wait.
wire.
Just a minute. Wait.
Okay, you have to just do one thing. Just see here. You cannot find. I think this is little
No, no,
bit.
it's on magnetic field P, right? So from point P, if I take my right hand, it's
No, no,
going
no, no,
inwards.
no. Actually, the thing is, no, this time the thing is that this is your XY plane.
Yes, sir.
This time, this is your screen of your laptop. I have told you this is your XY plane. Now I have rotated XY plane like this, and this is the
Okay.
wire. This is the wire, and current is going in this direction. Current is going in the downward direction. In this direction, so what you will do? You will just point out your thumb in this direction.
Oh,
Point
okay.
out your thumb in this direction, and point out your fingers in the direction of point out your finger at a point where you have to calculate the magnetic field. So what you will do, and you will curl your finger 90 degree like this, means you are
Yes.
getting the direction in this direction, means in the positive x-axis.
Positive, sir. Yes, sir.
Yeah, in this direction is positive x-axis direction.
Yes, sir. So I
the
cap.
I cap. So knowledge of plane and axis. So you can see the examiner can give you this type of thing also for and you will get confused and you will say the direction. You cannot say that direction will always be along x-axis, always be along the z-axis, always be along the y-axis. Accordingly, the direction can change. Now you can just add both the vectors. V1 plus V2. So when you will add both the vector, first you will take common. 2 mu naught 4 pi d is common.
Yes, sir.
2 mu naught 4 pi d is common, and remaining thing will be here minus
Yes,
I1 into
minus
k
I
cap.
cap.
So this
Yes,
will
sir.
become minus I1 into k cap, and this will become plus I2 into I cap. Okay, minus I1
Yes.
into k cap and I2 into I cap. So this is the direction, whole direction of the magnetic field.
Yes, sir.
So this is your answer.
Done,
So you
sir.
can. Okay, Harsh. So that's all for today. In the next class, I will discuss. Have you got na? Means how the
Yes, sir. Yes,
direction
got
is
it.
like this. How the direction is like this means
Yeah,
you
it's
have.
downwards. The current is downwards.
Don't think that. Don't think this plane always remain thing. You can fold the screen of your laptop like this also. Okay,
Yes, sir.
the plane can change. The examiner can change the plane. This time the current is going in downward direction. So that is why you
Yes,
are applying the formula and you are getting
I
the
am.
direction of magnetic field in this left, or you can say right side. And right side is the positive z axis. So that is why I have
Z-axis.
written I cap.
Yes, sir.
So Harsh, next topic is the magnetic field at the center of circular arc, and this we will discuss in the next.
Next. Okay.
And I will talk about the timings. Okay, no problem.
Okay. Okay, sir.
Okay.